Everyone. I, Hina Choksi, on behalf of Faculty of IT and Computer Science, welcome you all to today's webinar session. I heartily welcome today's webinar speaker, Dr. Jaideep Singh Raolji, Dr. Priya Swaminarayan Ma'am, Dean, Faculty of IT and CS, Professor Vivek Dave Sir, Head MC Department, all faculty members of FIT-CS, and all my dear students. Before starting the webinar, let me give a brief introduction about Dr. Jaideep Singh. Sir is having more than 20 years of experience and holds a dual degree in Masters and also has done his PhD from Dr. Babasaheb Ambedkar Open University, Ahmedabad. At present, Sir is currently working with as an assistant professor at School of Computer Studies, Ahmedabad University. He has also been associated with Maharaja Sayajirao University as well as Gujarat University. Sir also holds Sun Certified Java Programmer certification as well as is also a member of Computer Society of India. Sir has been teaching various subjects during his tenure, and the major subjects that he has been teaching is in the different UG and PG courses, including the latest topics and the trending subjects like cloud computing, natural language programming, then you can Java programming and many more, right? Sorry, NLP, that is natural language processing. He has published more than 10 research papers in reputed journals and also have presented many of the papers in the reputed conferences. So without wasting much time, I welcome you, sir, on behalf of our department, and I request you to please take over and brief our students with your knowledge related to NLP. Over to you, sir.
Yeah. Thanks, Professor Hina. And I'm also thankful to Parul University for giving me this opportunity. So without wasting time, I will start with this webinar and I welcome you all, okay? So I will just share the screen. Yeah, is it visible?
Yes, sir.
Yeah. Okay, so thanks a lot. So welcome you all on this webinar series. So I'll be conducting a webinar on natural language processing. And my agenda for the today's session will be, I will be covering AI and NLP, NLP basics, character processing, words, and I will be covering two statistical model, BOW model, TF-IDF model, and if I will be getting a time, I'll be also covering probabilistic reasoning, that is N-gram model. So moving further, so starting with what is artificial intelligence, because everyone knows that natural language processing is a subpart of artificial intelligence. So we already know that artificial intelligence is nothing but if a program or a machine learns like a human, okay, reasons like a human, and solves problems like human, we can say that that particular program or a machine exhibits a property of artificial intelligence. So if I just say, as I said in my earlier slide, that NLP is nothing but a subfield of AI. Now, the first question each and every student, because I'll be considering that there are most of the students who are attending this session. So in that sense, clear, the most common thing that students must have a question whenever they just think about natural language processing is that we know what is programming language because they have worked with a lot of programming languages, okay, during their MCAs and BCAs or BTech. So they might have learned C, C++, Java, and Python, clear. So they know what is programming languages, but whenever just see this term natural language, they just bogged up. So what is this natural language? If I just speak out examples, then oh yes, these are the natural languages. But yes, what are programming languages? They are very well acquainted with. So if I just give an example, natural languages are like English, Gujarati, Hindi, Marathi, clear, and so many. Clear. While programming languages, you already know, like C, C++, C#, Python, Java, and so on. Now, what is the difference between these two languages, natural language and the programming language? Okay, because if I want to process programming language, we know as a computer science students, we know there are so many tools available, okay, right from interpreters, compilers, and scripters. There are so many things available. But whenever we think of natural language, clear, it is not that simply a compiler or simply an interpreter will solve all the issues related to languages, okay, that we speak daily, like English, Gujarati, Hindi, Marathi, right? Clear. So the most differences that we found between natural language and a program languages are the most common. As we know that obviously natural languages are evolved as a human to human communication language, while programming languages are used to interact with computers, because we know that computers know only binary language, and if we just come to the CPU level, we can say that it knows assembly language, okay, but not the human language. But still we are typing our programs into human understandable form language, at least to some extent. If you just consider Java, Python, C++, at least we are acquainted with the commands which are there in English. But still it has to be in a structured way, right? Programming languages, each and every statement, if you see each and every word, they are arranged in a specific order, right? And has specific context, while in case of natural language that doesn't happen, okay. So that is the real challenge, okay, behind the processing of programming natural languages. Now, if you just think the difference between natural language and a programming language is, if you just consider natural language, it is a huge library. It has a large vocabulary. Clear. If you just look at the detailed dictionary, okay, it is more than 2,000 or 3,000 pages. Now just consider how to process those dictionaries, right? Again, clear. To add that, it has large number of rules, okay, clear. And there are so many even exceptions within those rules, right? So if I just consider a verb rule, okay, there are thousands, there are more than, if I consider an English language, okay, there are more than 50 rules, okay, which are based on only verbs, okay, including all those exceptions, right? Now just consider how difficult it would be, clear, if I just create a program which is a rule based. It's really very difficult, okay, to process those natural languages using rules, right? Similarly, if you look at programming languages, it has a limited vocabulary, okay. So if you just look at the keywords, okay, there are 50 to 60 keywords in a programming language, okay, right? And there are functions, and each and every functions, clear, are named, okay. And there are again rules, okay, for naming those functions, right? So that means, clear, it is approachable by rule based programming, right? So in case of programming languages, so we can say that there is a limited vocabulary, limited rules in programming languages. So they become very easier to process, okay, using a normal rule-based programming, okay, by creating compilers or by creating interpreters. But in case of natural language, clear, as I said, it becomes a challenging task. Yeah, the most challenging task is natural language are more ambiguous. They are highly ambiguous. If I just look at this first sentence, if I just consider this sentence, okay, if you just look at my cursor, if I look at my mouse pointer, okay, so if you look at this sentence, computer science students are drawing tree. Okay, so it looks fine that, okay, computer students are drawing tree. So if this student is looked at the perspective of computer science students, someone may know that, okay, the computer science students might be drawing a tree which is related to data structure, okay, not a biological tree, okay. But clear, what is the important thing is, we have, how would a machine know this? Okay, as a human we know that yes, computer science students obviously drawing a tree. A small kid, if he is told to draw a tree, obviously he'll be drawing a biological tree. So looking at the context, okay, that computer science, clear. And then if you are having a tree, we can say that yes, it is a data structure. Okay, if I say a school student, maybe a biological tree. That means you have to find out the context and look at the context. Clear. If I just look at the tree, okay, and how many words the computer science word is far away, okay, from tree, right? That means within a sentence you have to find out the context. Then only this removing this ambiguity is possible, clear. And again, who knows, computer science student can also draw what, clear, a biological tree, clear. So again, clear, is it is a matter of pragmatics. Similarly, if you just look at this Gujarati sentence, tapeli chulha par tapeli chhe. Now what is this tapeli, first tapeli, and what is this second tapeli? Clear. As a human we know, because we have learned so many sentences, okay, right from our childhood, clear, till this age, Okay, since so there are 40 years that we are having a huge amount of data, that is corpus in our mind. Okay, so that's why we are easy to then we say that okay, it's very easy that tapeli means that is the utensil. Okay, and chula upar tapeli che. Okay, and this the last second last tapeli clear is nothing but it is a property of heat. Okay, it is hot, right? Clear. So the, both these words look similar. Okay, but the meaning is totally different. Okay, so these are the challenges we face clear in case of natural languages. While if you just look at those programming languages do have ambiguity. Okay, but clear they are syntax based. Okay, their syntax is what we can say is static. Clear, we can make out the syntax. Why? Because those rules are created by humans. Okay, and they are not tend to be changeable once you design your programming language, right? So if you just look at this particular three statements clear in a programming language like C. So in C, clear, if we write in star p, okay, now star if we see clear, it has obviously many meaning. Clear, it acts as a multiplication sign, it acts as a pointer operator, it acts as indirection operator. Okay, but if you look at this first statement in star p, clear, I would say that here star is nothing but a pointer operator. Why it is a pointer operator? Because I know that on the left hand side there is a name of the data type and on the right hand side there is a variable name. Then obviously it won't act as a multiplication sign. Okay, it doesn't give your compiler, right, doesn't give any compile time error, right? It will just compile it and create what a pointer. But the same star sign, okay, if it is surrounded by two variables. Okay, if you look at this second statement, now here what will happen? A star B. So here star sign acts as a multiplication sign. Okay, that means if the context is both the variables on LHS and on RHS, it acts as a multiplication sign. Similarly, if I just use ampersand B, okay, and on the left hand side, if I put star sign, the same star sign acts as an indirection operator. That means it gives me what? Address, clear. If I just provide address of B, it will give me value at that address. Clear, what is the value at that address? Okay, at address B. Clear. So that is how clear ambiguity is very simple to solve in case of programming languages. Okay, because the syntax, clear, the syntax is defined, already defined, okay, by the rules, right? Clear. While in natural languages, clear, there can be so many words in between. Clear, between these two tabeli there cannot be always two words, right? There can be many words. Hence, clear, the challenge lies in removing the ambiguity. So these are the challenges we face to process natural languages. Clear, and we already know that a natural language can be translated to several languages, and we normally for a programming language, clear, our aim is always to translate to a machine understandable form. Okay, maybe an intermediate form in case of Java. Okay, the source language is converted to bytecode and then bytecode is converted to machine understandable form, right? So that is how clear the translation occurs clear in case of programming languages. So ultimately, if I want to define what is a natural language, okay, so I can say that natural language is nothing but it can be used to express feelings and thoughts by humans, right? Or in other sense, clear, encoding and decoding the information. So whenever I am speaking, I can say that I am encoding the information, and you are at your end, clear, listening to me, okay, and you are decoding the information, right? Clear. Similarly, already we know that if you look at the history of natural languages, okay, so during old days no one was having the technology, okay, to what we can say record what humans speak, okay, and then paper came, okay, and then recording started by using what scripting. Okay, so we normally use Devanagari script. Okay, Devanagari script is scripting resource, okay, which is used to write normally, or it can be used to write all the languages, right? Clear, but normally it is used to write Hindi language, Marathi, okay, then Sanskrit. Clear, we write Gujarati language, okay, in a Gujarati script, which is nothing but a modified form of Devanagari. Okay, we are well acquainted with English. Whatever you see on my screen, clear, is again a script. Clear, it is not called as English language, right? It is not called as English language. Okay, it is what? It is a Roman script. Clear, or you can say it is a Latin script, right? Clear, and belonging to English. Yeah. Coming moving further. Now, if I want to process a natural language, clear. As we know that natural languages are not machine oriented. Okay, they are having very free flow. Okay, they are nothing to do with computer machines. Now, to process this, okay, we must have a knowledge of linguistics, then mathematics, then statistical models, clear, then obviously computer algorithms, because you require huge amount of data, and where to store efficiently this data. Obviously you require data structures, then to process these data structures you require knowledge of computer algorithms, and obviously to make it permanent, to store permanently, clear, we can have file and database management, right? So a knowledge of all these aspects will help us to process a natural language. Okay, and if I want to process a natural language, so now we start with how to process, or which are the main pillars, okay, which are there in NLP, which will help us to process step by step the natural language. Okay, so one is lexical or a morphology. The lexical stands for relating to processing of single word, clear, which is also called as morphology. Okay, it is related to word. Then in the second step we come to syntactic. Okay, that is syntactic means how the words are arranged, clear, in a particular sentence, clear. So normally it also starts with characters. Okay, I have not just mentioned here characters, but normally it starts with characters, A, B, C, D. How to process that? Okay, ka, kha, ga. How to process single characters? I will also come to that point, clear, in my next slide. So the next is syntactic. Syntactic means if I am having a sentence, clear, how those words are arranged, okay, within a sentence. Okay, what is the pattern? Clear, how pattern looks like. Okay, then there can be so many patterns in natural language, right? Clear. Which of the pattern is always most repeating, clear, more probabilistic than any other pattern, clear, there comes statistics, right? Clear. Then semantic, relate to meaning of word. Okay, what is the meaning of this particular word? After looking at those arrangement of words, clear, the next phase that come across, clear, natural language processing is, clear, what is the meaning of the word? Because without getting the meaning of the word, clear, how do we just what we can say, get the meaning out of the whole sentence? Okay, that comes under semantics. And even more than that, pragmatics and discourse, clear, pragmatics and discourse requires a huge amount of knowledge, even if I want to process a single sentence. Say for example, clear, if a student comes just enters in my class, okay, and he is late by 5 minutes, clear, and if I say, okay, you are so early today, so the meaning lies where, if I just translate it, okay, clear, then it will say that yes, the student is early today, but actually he is not. Okay, I am using some satirical sentences. Okay, okay, I am having a satirical meaning, right? Clear. So actually the student is late. Actually the student has come late. Okay, but clear, I am using some satirical sentences. Now you, if I want to process this word, this particular sentence, I need to have the worldly knowledge. Okay, so when my class starts, okay, how many minutes have been elapsed, okay, till my class has start, who came, okay, and then the processing starts, clear. So that is a huge challenge in natural language processing. Okay, that is huge AI topic. So that is pragmatics and discourse. Moving further now, just after giving this background, you would know that what can be the applications of NLP. So this I have listed so many applications of NLP here. Automatic summarization, then information retrieval, clear, then part of speech tagging, sentiment analysis, clear. If I just go one by one, clear, you already know what is machine translation, because most of you are using Google Translation or Bing Translator, or many translators which are available, clear, but these are the open source, clear, and freely available, right? Bing and Google. So you might be using this. Okay, entering sentence in one language and translating into another. Similarly, stemming and lemmetization. Now, this one is the most important application which is available in NLP, and uh, the most important thing regarding this stemming and lemmetization is, the important thing is it is used for most of the processes. Okay, whether you want to do machine translation, clear, or named entity recognition, clear, or part of speech tagging, clear, text summarization, clear. This is the most common thing that each and every NLP a programmer requires. Okay. Now, what is stemming and lemmatization? Stemming and lemmatization is removal of suffixes, clear, or prefixes, and to get the root word. Okay, to get the root word. If I just consider a word running, okay, if I just give an example, a word running. Now, if I just look into the dictionary, what is running? I may not get that particular word. Okay, the meaning of running. But if I just look for the word run, 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 then yes, the word is available in the dictionary. That means clear. In that case, what I need to do is each and every word needs to be break down to a root word, okay, or to be brought down to a root word. Now, how to do that? Stemming and lemmatization, clear, is the answer for that. Clear? Okay, so if I'm saying running, 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 okay, just remove what ing. Okay, it will say RUNN, run. Okay, now that is the task which is done by stemming. Okay, stemming does that. Okay, if you look at this example even, okay, if I take a word generation in English, okay, so this is what generation, GNERATION. So normally according to the rules of grammar, okay, I will remove ION. Okay, I will remove this ION. So if I remove ION, what will be my resultant word? My resultant word will be generate. And if I look into dictionary, okay, if I'm going in for semantics, right, and if I look this particular word into a dictionary, I don't find this particular word, right? So that is how stemming works. Clear? That is how stemming works. If I come to lemmatization, okay, lemmatization is also a similar process to stemming, that is removing what affixes or suffixes and getting the root word. Now, if I use lemmatizer, okay, what it will generate? It will generate the exact word generate, okay, which is there, which is available in the dictionary. Okay, the meaning is to the mean to say the meaning, okay, that I want to come to the conclusion is lemmatization uh, is more accurate than stemming. Okay, lemmatization process is more accurate than stemming because you are getting the exact word, okay, which is there or which is there available in the dictionary. Okay, while stemming doesn't do that. Understood? So you might feel that okay, then lemmatization are best. Okay, but it is not so. Okay, it always depends upon your kind of application that you are working on. Right, clear. Say for example, if I am working on machine translation, okay, or if I am working on text summarization, then I require an exact meaning of that particular word, okay, to get it from the dictionary. Right, clear. So in that sense, clear, I may use lemmatization. But wherever you don't find this accuracy, you may feel that accuracy of 90 or 91%, okay, will be sufficient for my application. Then you can go for stammer. The reason to go with stammer is they are very lightweight and they are much faster. Okay, while lemmatization, clear, they are very heavyweight because after getting or after removing the prefix and suffix from the word, clear, it also looks within the dictionary and checks, okay, and verifies whether that particular word is available or not. Dictionary or a word net, okay, it can look for a word net or a dictionary. So that is how stemming and lemmatization works. Similarly, if I give another example, this Pushpani is a Sanskrit word. Okay, it is a Sanskrit word. Okay, and Pushpani, okay, that means giving a flower, okay, to someone. So Pushpani, right? So actually, if I just remove ani, there are so many Sanskrit rules in Sanskrit grammar, okay, which defines what all these suffixes and prefixes which are given to the word. Okay, so if I apply those rules and remove those or just strip off those suffix, I will get what the root word. So if I just use a stammer, now in case of stammer, ani is the rule, okay, in Sanskrit. So if I just remove ani, clear, if you just look at this word puspani where it is I have colored with pink, if I just remove that, clear, you will get what puspa, right? But if I just look into dictionary, I won't get puspa, and ultimately I will land up to a result that yes, puspa is some name of a person. But no, clear, actually I want to know what, clear, puspa is a flower, right? Clear. So in that case, what should I do? Clear, in this case, clear, your lematizer works well, right? Because it gives you what, push as your answer. Similarly, if I just look at a Gujarati word and which is a verb, okay, if I just work with a verb, okay, Ramish, right? Now Ramish is not available in word, okay, but in a dictionary or in a word net. But clear, if I just remove ish, so there is a rule in Gujarati also. Clear, if I just try to remove ish, clear, I will get what, ram. Okay, ram is a root word. Okay, now I can process this particular word, okay, or add some other inflection, okay, and convert to some other tenses also. right? So this is, there comes what natural language generation. So that is how clear you can generate your own sentences also with different tenses. Clear? So that is stemming and lemmatization. So stemming and lemmatization plays a very important role. And another thing that I want to emphasize here is clear. There is lot of work done in English language. There are standard stammers and lemmatizers available clear for English language. Just in NLTK, okay, Python Analytical Library, we are having Porter stammer, clear, then Lancaster stammer, okay, then there are so many stammers available, okay, which are standard, but still clear standard stammers are not available, okay, for Indian languages, right? It is still not available for Indian languages, and they are not as accurate as the English languages. So still there is lots of work needs to be required to be done at this level also. Okay, so yes, so there is another application which is spam and not spam. This we are already experiencing our in our email. Okay, email notifications. Okay, automatically clear email goes clear in spam and not spam our inbox. Okay, so how that is done? Okay, by looking at the contents. Okay, if I just find out some particular words that are most repeating, that you are winning the lottery, clear, you are having this bank statement, clear, and you will be having a two, then I can obviously put those word into clear a spam category, right? Put those email into spam category and not spam category. That means looking at those words, okay, if those words are frequently available, that means I have to count those words, okay, within that particular email, okay, and if I found those words clear more frequently available, okay, I can put into spam, clear. So again, that is an application of an LLP. Then sentiment analysis, clear, if I'm having a particular sentence, clear, can I say that this particular sentence is a negative sentence having a neutral value or a positive value? Right? If I just find a word like brilliant, clear, very good, then I can say yes. Is it a positive? It is a positive sentence. If I say bad, clear, sad, I can say it is a negative sentence. But if I say not bad, okay, now not bad means it is a positive sentence, right? That means here I have to look for not only single word but collocative words. Here comes a bigram. Okay, here comes a bigram model, right? Clear. So this is how clear all these concepts clear of NLP will help you to create different kinds of applications of NLP. Similarly, yes, spelling correction. Clear, there are so many spelling corrections tools available for English. Again, I want to reiterate, clear, no standard tools still are available for Gujarati, Hindi languages. Okay, clear. Then this is also text summarization and information extraction applications of NLP. Yes. Okay. Now I will start with how to process. Okay. So up till now we had seen clear the introduction of NLP, the kinds of applications that we can create. Okay, using NLP. Now moving further. Now, as I said, okay, in my previous slide, that it starts from character processing, word processing, okay, then sentence processing, and then whole paragraph processing. Understood? Now, if I start with a character processing, we know that computers doesn't understand even characters, not even ABCD, right? Clear English languages, because we know that computers completely understand what numbers, right? Clear, and that too only that too one and zeros. Okay, but we will not go until one and zeros, but we will restrict our numbering system to a decimal. Okay, that is 1 to 0 to 9, right? And if we just look at all these characters A B C D K K G, okay, what is happening to those words? Are these particular, sorry, are these characters understood directly by our computer's hardware? No. Okay, whenever we say A, whenever we say B, always clear in back of mind, clear, it strikes that no, it is an ASCII code, right? Clear. A has ASCII code which is 65, B is 60, B is 66, C is 67. Similarly, K, K, G. Now what will happen to that? Because we know that ASCII code ranges from 0 to 255. It covers only Roman letters, okay, or Latin script, right? Clear. Now what about K, K, G? Okay, then Hindi ka kha ga. Not we cannot say Hindi, but we can say Devanagari ka kha ga. Now what will happen to that? Now again, all these characters are having what? Clear a code, which is known as what? Unicode. Clear, we can say universal code, right? Similarly, ka. So ka kha. If I just show you, yes, if I just show you a Unicode table, clear. So this is the code point for Gujarati. Okay. So if I just start with Bindi, okay, 2689. Clear? Then if I just start with a vowel marker it is 2693, right? So what is this? Okay, these are not ASCII codes, right? Clear? But it is a Unicode. So Unicode range starts from 0 to 65,536. Okay, Unicode is a 2-byte code, right? Clear? So similarly, if you just look at this, each and every character, okay, has a code point. Clear? Corresponding code point, right? Clear? If you look at this diacritic marks also, look, okay, if you just look at the Kanumathar, okay, it is 275 and 2752. That means each and every clear diacritic marks as well as clear a full character is having what? A Unicode point. Okay, so that is how it gets processed. Again, coming back to my presentation. So as I explained you, clear how all this characters get encoded. Okay, so obviously clear, you may feel by looking at this code that but ABCD, a character which is there in ABCD will obviously occupy less space than Gujarati ka and Gujarati ka. The reason behind that already you have just seen, right? Clear that it is a Unicode point, and Unicode point value was around 2560, and it is obviously not accommodated in 1 byte. It requires 2 byte, right? Clear? So that is how those characters are encoded. Yes, already talked with that. Yes. Now, what is just I showed you this particular character encoding set. Now, what is the purpose of this? Right. Clear. So obviously, the first concept that I would cover is transliteration. Now, everyone does not know the word transliteration, but everyone is working on it, because we know that typing in Gujarati or typing in Hindi is very difficult on mobile. Yes, clear. So if I want to send a message in Gujarati, okay, what you will do on your WhatsApp, right? You will simply say, clear, hum abhyas kar rahe hain. So if you look at this last line, clear, if I say hum abhyas kar rahe hain, so what is this? Is this an English language? No. Okay, it is a Hindi language. But if I say which script you are using, okay, then I can say I am using a Roman script. Okay, I am using a Roman script, right? Clear? So all these three sentences, okay, all these three sentences belongs to Hindi language. Okay, even the second sentence, okay, I have written in which language? If you just look at, okay, it is a Gujarati language. No, it is not a Gujarati language. Okay, we can see it is a Gujarati script. Okay, extended Devanagari Gujarati script, right? Clear? But it is a Hindi language. Clear? Because if you just look at the sentence, okay, just speak out. Okay, if you just look at the phonetics of this sentence, हम अभ्यास कर रहे हैं. Okay, it is nothing but a Hindi sentence, right? Similarly, if we just look at this first two sentence again, clear, her, then ma. Okay, each and the best quality of Indian languages, okay, that I want to emphasize on is clear. They are very phonetically strong languages, phonetically and scriptically, both in both the sense they are very strong. Very strong in the sense whatever I speak, that can be exactly encoded in case of Indian languages. That doesn't happens with what we can say English language. Okay, if I say tapan, okay, in English, so what is the spelling of tapan? It is saying Tapan, right? Can I say tapan? Yes, obviously, it is exactly true. Okay, it is no harm in saying tapan. Okay, can I say uh, can I say tapan? Yes, that is also fine. Okay, there is no harm in it. Why? Because English language is not phonetically strong. Okay, whatever you speak, it is not exactly written in that way, because it has what we can say clear. It has the scripting set, okay, is not strong as the Indian languages. Okay, while in case of Indian languages, clear, whatever we speak, okay, in whatever form, okay, that can be exactly recorded clear in form of scripting. Okay, so that is how clear Indian languages are scriptically strong. So if I just look at a transliteration example, right? If you just look at this hum, okay, it is just encoded in two characters in Hindi also, as well as in Gujarati Devanagari script also. But if you look at this HUM, it requires three characters. Similarly, Abhyas also, right? Clear? So that is how we can say that the transliteration between Indian languages is easier, okay, but transliteration, okay, between Indian languages and in English languages, which is also known as Romanization, okay, that becomes a challenging task. Clear? So that was explaining that for Indian languages, as I said, they are very strong. Just wait, sorry. Yeah, sorry. So, yes, I was just explaining that why Indian languages are very strong phonetically as well as scriptically. The reason is this. Okay, as each and every sound. Okay, starting from our voice box clear to our tip of lips. Okay, to the end of the lips. Each and every word. Each and every sound is is having what equivalent character. Okay, it has having equivalent character. Yes. So if I want to perform transliteration between Indian languages, it is easy. Okay. But yes, clear between Indian languages and English, okay, it becomes difficult. It becomes challenging because there are words. So sorry, there are sound which require combination of two characters to encode it. Clear, which is also known as romanization. So there are so many romanization schemes available. Clear, like IST, then Harvard Kyoto, Trans, iTrans, Weltius, and these are the example. I have just given iTrans, right? So this is the encodings. Clear. I have just correspondingly arranged the encodings of Devanagari, then Gujarati letter and English. Okay, and English I'm using iTrans. Okay, so if you will just get an idea. Okay, so this helps in transliteration. So if I want to build an application which is transliteration based, clear, I will just show an example. So can you see my screen? Yeah. So
Yes.
whenever, yeah. So I just decided that I will go with a webinar, okay, with a little bit of practical approach. So you don't find only theoretical aspect. Okay. So if you just look at this implementation also, so you will get an idea. So I have I'm having implementation of TF-IDF model, BOW model also. So you get more idea that okay, theoretically how it is implemented. Okay. Through program. So if you look at this program, it is very simple program. You might have already done okay during your BC and MC level also. The most famous program that you might have done is converting smaller case letters okay to uppercase and uppercase to lowercase. Okay, the same thing is here. Okay, there is nothing new here. Okay, so here what I'm doing is I'm converting a Gujarati script. Okay, so if we just look at this particular program, okay, I'm opening this file story gujarati.txt in a read mode and story hindi.txt in a write mode. Okay, that means I'm reading this file story gujarati.txt. If I open this file is available here. I will increase the font so that you can read. Yeah. So so this is the story. Okay. We don't need to go into details of the story, but just look at this. This is a Gujarati script. Okay, and the whole story is in a Gujarati language. Right now, I will convert this into a Devanagari script. Clear, and it is very easy. Okay, and it is very easy. So I have just closed that. Okay, and just if I run this, what I have done is I am just reading this particular file by using this function fu.read. Okay, so my data will be available in ch, and if I just look here one by one, I am accessing clear that particular character. Okay, and if it is in the range 2688 to 2815, now already we had seen that particular table. Okay, so if this is the range, clear, what I will do is I am converting to a Hindi script, clear, Devanagari script. Okay, and it is very easy. Clear, as we know that converting an uppercase letter to a lowercase letter is very easy because the difference is of 32. Similarly, here the difference is 384. Okay, between all the characters and all the diacritic marks also. Diacritic marks means clear the kanu, mattar, e, u, all those rasvos, right? So if I just run this application, you will find the result here. Okay, so you just if you just look at the result, look here, Akbar Birbalની સાથે સાંજે બાગમાં ફરી રહ્યા હતા. So though it looks like a Hindi, a Hindi script, okay, but ultimately it is a Gujarati. Clear? So this is the most simple transliteration application which can be built, okay, using uh, the knowledge of Unicode characters. Again, coming back here. Yeah. Now coming to the bag of word model. Now directly you might have wondered that sir has explained clear how to process particular characters. right? Clear. Now directly, what is this bag of word model? Now what is this bag of word model? Now I will come on the processing of the word. Yes, clear. The first thing that I want to inform you is word can be processed, okay, through language rules also, okay, by writing language rules. But as I said, there are huge amount of language rules, there are so many exceptions within those language rules, so it becomes very difficult to code each and every rule, okay, with exception, and we might not get what we can say, clear, a good result, right? Clear. So the best way to do clear, to work in natural language is always go with machine learning models. Clear. Always go with deep learning models. Clear. Why? If you are having corpus, okay, another thing, another question that you may raise, that why always machine learning model, why always deep learning model, why not rule based? Clear. Now it always depends upon, clear, the kind of application or the kind of domain you are working on. Clear. Now for example, clear, if I am working on some language, say for example, say if I just say Marathi. Now, Marathi language doesn't have much resources. Clear. Okay. Now the resources has been built, but still we can say that it is not resource rich as an English language. Clear. That can be said. Clear. Similarly, Sanskrit language also. Okay. Sanskrit language is not rich in resources. Right. It doesn't have huge amount of a corpus. Right. Clear. So how do we process using machine learning models? Because machine learning models and deep learning models require huge amount of data to build their statistics. Okay, clear. So we require huge amount of data. Data's in GBs, okay, for deep learning. Okay, and data's in almost MBs for machine learning model. Right, clear. But if the data is not available, if the corpus is not available for such rare languages, okay, like Sanskrit, okay, like other African languages, okay, like Burmese languages, then then what is the solution? Then the only solution remain, clear, is to, one is collect the corpus. Okay, the one solution remaining is that you collect the corpus, you create the corpus. If you are not able to create the corpus, you can work on the rules. Clear. Working on the rules, you create your corpus and then start working on your through machine learning approach or a deep learning approach. Right. So it is always a trade-off. Clear. It is always a trade-off you have to make. Right. Clear. So if the resources, language resources are less, you have to rely on rule based model. If the resources uh, are more available for any of the particular languages, you can work with machine learning model. If the resources are, there are huge amount of resources, huge and huge, which goes in GBs and TBs, you can work with deep learning models. Clear. So depending upon the type of availability of corpus, okay, you have to decide, okay, whether I can apply the machine learning model or a rule based model, clear, or a deep learning model. Okay, and this is a bag of word model. Now bag of word model helps in a machine learning model, okay, because it acts as a feature. Okay, if you have an idea of machine learning, okay, machine learning completely works on feature. Now what are feature? Clear. How to do feature engineering? Feature engineering, I will come to that particular point. Right. Clear. So how to find out the feature? Right. So bag of word model is one feature for a machine learning technique and even a deep learning technique. Okay. Now what is a bag of word model? Bag of word model is very simple model. If you just look at this particular, so I have created one Excel sheet. Are you able to read this font? Uh,
Yes,
uh,
sir.
yeah, okay, thanks. So if I have just created Excel sheet, okay, the same Excel sheet I have programmed in Python also. So I just I'm just not directly moving to a program, because it will be very difficult to understand directly a program. But if you just look at the Excel sheet, okay, this the everything has been completely modeled, okay, in Excel sheet, the whole BOW model. So whatever normally what it requires, so these steps you need to follow before building a bag of word model. Okay, BOW stands for bag of word model. Okay, clear. That is a bag full of words. You can think like that. Okay, that means you are having a bag which is full of words. Now, if you are having a bag of words, obviously in that particular bag of word, clear, all the words are, we can say it is tokenized, right? And they are randomly placed in the bag. That means there is no importance of what? There is no importance of sequence. So that's why if you just look at this particular point in my slide, here I have written, yes, order of word is not important. Obviously, clear, if all the words are there in the bag which is randomly placed, obviously the order of word is not important. Okay, it won't help me. Clear. So it only talks about what? Bag of word model only talks about multiplicity, right? That means how many times that particular word is appearing in the document, right? Clear. So coming back to this particular sheet. Okay, so I have taken these three sentences. So I have just written here all three lines below is a corpus. So this is my corpus. Actually, corpus tends to have huge amount of sentence. There are large number of sentences. Okay, clear. But clear. For example, I have taken only three sentences. Okay, so this is my very small corpus. Okay, this book and this is a book and this book is really nice. Clear. It is a biology book and it belongs to Manu. So these are the three sentences I'm taking here. Okay, now if you look at this particular cell, I have written vocabulary of 12 words out of 19 words. That means what are those 19 words? So these are the total 19 words. And what are those 12 words? 12 words are unique words that I have fetched from this particular corpus. Okay, and I have built a vocabulary. So that is known as vocabulary. Clear. In aspect of natural language processing, right? So whenever you come across to read a natural language process or to work on natural language processing, if you find a vocabulary, clear, just think that vocabulary is nothing, okay, but set of unique words, okay, from your corpus. So if I just look at this, a, and, belongs, biology, all these are unique words which are available, clear, from those three sentences, okay, or we can say from three documents, right? Clear. And if you look at this first document, okay, this is my first document, this is my second document, and third document. So many document makes a corpus. Okay, so this is one. Clear, this is one. Now what is this one? How it is, how the one is coming? So here I'm what I'm doing is I'm vectorizing, right? I am vectorizing means, clear, again I will reiterate that all the machine learning model, clear, the deep learning models doesn't works on words. Okay, they doesn't understand word, they doesn't understand what is a, what is and, what is biology, what is book. Okay, they only understand what? Numbers, right? They only understand numbers. That means ultimately, clear, by anyhow we need to convert each and every word, right, to a number. Okay, clear. So here in this case, a is converted to 1, right? Clear, for sentence, for document number 1. Clear, similarly 1. Now what is this one? That is nothing but a count of that particular word in that particular document. Clear. Similarly, if you look at this book, book is 2. Why 2? Look here. Okay, the book word is available twice. It is available here also, as well as it is available here also, right? So that's why it is 2. Okay, so it is very simple. Okay, it is nothing but talks about the frequency of words in that particular document. Okay, so this was sentence 1. Clear. Similarly for this is for sentence 2 and for sentence 3. Understood? So if you look at the overall corpus, we can say that A is encoded as 2 and 1 for this document. Clear. And is encoded as 1. Clear. And also 1 for this particular document, right? Clear. So this is how, clear, all these vocabulary words are converted to vectors. Okay, so this is a simple BOW model, right? Okay. Now, if we think in terms of machine learning sense, okay, or a deep learning sense, right? Clear. What is this A? Okay, and what is this 2? Okay, we can say that A is a column. Okay, this is column 1, this is column 2, okay, whose title is and, whose title is belongs, whose title is biology, whose title is book. So these are nothing but features, right? Okay, so all these words are acting as a features for a machine learning algorithm, right? Clear? So this A and, belongs, biology, book, okay, all these columns are nothing but features for a machine learning algorithm. Okay, if we just talk about deep learning, what happens in deep learning is, even you don't have to define these features. Okay, at least in a machine learning model, you have to say that yes, consider this particular A column as a feature. Okay, consider belong as a feature, consider book as a feature, don't consider and as a feature. Okay, consider eat as a feature, don't consider manu as a feature. Okay, you have to decide in the machine learning algorithm, right? So feature engineering. Okay, that means the best features that you decide for your machine learning algorithm, clear, the best output you will be getting. Clear, you will be getting the best output. But if we just talk about deep learning in the sense, okay, in the sense of implementation is much easier. Why? You don't even have to think about of all this feature. Okay, So feature extraction also takes place automatically in case of deep learning. Okay, it find out clear the appropriate features, clear also select the features. Okay, that is what a deep learning algorithm do. Right, clear. The main thing is you need to have huge amount of corpora. Okay, clear. Okay, so if you are using 20% of the corpora for machine learning, clear, I will say you have to use clear 100 times more corpus clear for a deep learning algorithm to train. Why? The reason is clear, your deep learning algorithm find out these features on its own. Okay, you don't have to give the features, okay, like in machine learning models, right? But yes, again, it always depends upon. You may wonder that then why should we go for machine learning? We should go for deep learning. Then I will question, do you have a corpus? Clear, right? So if you have amount of corpus clear which is available in large, clear, you can go for deep learning. Otherwise you have to work with machine learning models, right? Clear. If you just look, if you just think of Google machine translation, okay, Google machine translation, clear, in the beginning started with a rule base, right? Clear. Okay, after 5 years they started with clear a machine learning model. And just if you have just gone through some research paper, okay, right from 2016, okay, it is still very near, right? It has not even been a 5 years, okay. Still clear, just in 2016 it was a machine learning model, but now they are using what? Clear, a neural network, that is a deep learning model. Okay, now it is GNMT, Google Neural Machine Translation System, right? Clear. So they have throughout this years, 20 years, they have collected huge amount of corpus for different languages, clear. And then clear, after having huge amount of corpus for different set of languages, now they have implemented a neural machine translation, that is a deep learning approach. Clear. So that is how clear one should work clear in any field, okay, which requires a knowledge of machine learning or deep learning. So understood. So this is how a BOW model is built. Clear. Now, if I want to build clear this model programmatically, clear, you must have a raw text, right? We must have a raw text. Okay, then you have to clean that text, you have to tokenize the text. Here I have done it manually. Okay, but in program you have to do all this process. So if I just come to again a BOW model which has been implemented clear in a Python. Now, in Python you don't need to create a BOW model from scratch. Okay, why? Because there are uh, the reason for using Python is it is very rich in all these NLP libraries and machine learning libraries and deep learning libraries, right? Clear. There are so many languages available, right? Clear. You can work with Java also, you can work with C sharp, okay, for such kind of tasks. Clear. But why everyone prefers Python? The one reason is Python is not syntax heavy, clear, and it is very rich in library, and all its libraries are open source, clear. So that is the advantage of using Python. So yes, so to implement BOW model, you don't need to implement from scratch. If you want to implement from scratch, you can, okay, but clear, you can use what? Count vectorizer. So count vectorizer, it is nothing but a BOW model. Okay, the thing that you have to do is what? Just wait. Yeah, the thing that you need to do is what? You need to pass your text from this particular steps. Go from raw text to then clean the text, then tokenize, and then build vocabulary. So this building vocabulary and generate vectors, okay, that is done by your count vectorizer class. Okay, so these steps you have to follow, okay, while programming. So if you just look at this example, I have used count vectorizer, which is nothing but a building a bag of word model, clear, which is available in sklearn feature extraction.txt. Clear. I have imported analytical library, clear, and pandas. Actually, pandas is not required. This was just I have converted, okay, my results clear into an Excel file so that you can visualize, okay, clear. Otherwise, by looking at this particular output, you won't get a clear cut idea that what is happening, okay, behind the scenes. So I have just converted results and stored into Excel so that you will get an idea that yes, clear, this is how it works, right? So if I just come here, I have just taken a small corpus. So sentence is my variable and this is my whole sentence. Okay, so I'm working with the same sentence which I have worked clear in my Excel sheet, right? So if you just look at this level here, I'm just doing normalization, okay, or you can say this is nothing but a text cleaning. So sentences dot lower, converting my text into lowercase, Okay, then why to include tool in lowercase? Okay, we will just share. I will just share this discussion at the later stage. Then NLT dot tokenize dot send tokenize. I'm converting to sentences, right? Because this sentence needs to be converted to this particular. Say for example, okay, I'm having so many sentences, right? So this is one sentence, this second sentence. Now, how to break this into sentence? Okay, to break this into sentence, I have to look for a full stop. Okay, again, you don't have to write a logic from scratch. Okay, you can use this particular function sent underscore tokenize. It will automatically look for dot, okay, and break the sentences into single sentences, and all those sentences are stored into tokenized underscore sentence. Okay, so this is a list. Okay, this is a list of Python. And look, here I am doing what, if you just look at this, I will not explain the whole code, but only the key points within a code. So x dot replace, I'm replacing here full stop. That means I'm removing full stop because it doesn't have any importance. Okay, clear. Just think, if a machine learning algorithm looks for dot, what is the meaning of that particular dot? Yes, if I'm building an application, okay, for NLP, okay, which talks on forming of sentences, yes, then dot is important. Okay, then dot is important. But for other kind of application, I just need to remove those. So I'm just removing here x dot replace dot with, okay, space. Okay, so I'm removing the dot here. Similarly, clear, after removing those dots, okay, I am creating object of count vectorizer class. Here I'm creating object of count vectorizer class. So my BOW object is ready. Okay, now simply call this function fit transform. If I just simply call this fit transform and pass those tokenized sentences which I have cleaned here, okay, converted to lowercase and full stop removed, okay, what it will do, it will create what, the whole bag of word model. So now your bag of word model is ready, right? So if I just simply run this application, yes, so this is the output I'm getting, right? So if you just look at this output, okay, so look here. So this is where I have displayed a data frame. Your data frame is an panda object. Okay, you can just think or imagine just like your Excel spreadsheet. Okay, it is nothing but an Excel spreadsheet. Okay, it's a mirror image of Excel spreadsheet. That is a pandas data frame. So if you just look at this, okay, so this is 0 means your sentence number 1, sentence number 2, and sentence number 3. And this is how the whole bag of word model is created. Okay, and this will help us. Okay, now this is not a complete application, right? Clear, this is a part of one application. I can say, clear, ultimately I will use this feature. Okay, whatever features I have collected, I will use this feature in my machine learning algorithm, right? Clear, if I'm creating an application, okay, for POS tagging, okay, then you can say that yes, this is one feature that I'm using for my text summarization application. Okay, for what we can say, topic modeling, okay, clear, or information retrieval. So this is a part of that application, right? So if you just look at this, okay, the this results, okay, as I said, it has been saved to my Excel sheet also. So that is how it is saved here. Okay, so pd.data frame. So data frame, as I said, is nothing but you can consider that this is an mirror image of your Excel sheet in Python data structure. Okay, I'm passing this BOW, right? So this is my count vectorizer and TMP BOW and TMP BOW.to array. So it has been converted to array and finally to matrix. To convert to matrix, there is a function. Yes, this is to array, and finally clear, the whole 2D array has been saved into data frame. So it is saved where bwp.xls. Whenever I run that, I just created that file, and that file is available here. BWP. Okay, so BWP, that means bag of word generated through programming. So this is this was done manually, and look, so this is how the whole bag of word model, clear, is created by your that program, right? Clear. So these are all features, right? So these features are considered, clear, by your machine learning algorithm to work further. Clear. So this forms the basis for your ML model. Yes. Coming to the next model. Yeah. So yes. So as I said here, if you just look at this first point, clear, use for information retrieval, document classification technique, clear, and it can be used as a feature, okay, in a ML based uh, classifiers. Hello,
Yes,
hello.
sir.
Yeah, yes, Hina madam.
Yes, sir. We are nearly reaching
Yeah,
at the end of the
yeah,
session,
yeah.
so you can take accordingly.
Yeah, okay, okay. So I think the next model was TF-IDF model, but I could not cover it clear. Even I had planned to cover this probabilistic reasoning also, but I don't think it is possible now. So yes, I must end here,
Yeah,
Professor
you
Hina.
can wind it up the way you
Yes,
want,
yes.
sir.
Yeah, okay. So this is here winding up, and if you have any questions, you can ask me, students and anyone who are present here.
Yeah, sir. There are many students who have joined through the Facebook link,
Okay.
and I'll just go ahead with certain questions that I have just received from students. And okay, one of the most interesting question that I have received. That
Yes.
sir, does Google Map use NLP? Because generally, when we use Google Map, when we switch from the language that is the medium of instruction, right? When we change the language from Hindi to English, does Google Map use NLP?
Yes, Google Map does use NLP. Yes. Even whenever you're searching on map, through a map that I want to go to Ahmedabad city. So obviously it will strip off all those stop words and it will search for particular Ahmedabad word clear and it will find it within a map. Okay, so yes, NLP is there. So wherever you are having a language aspect, always NLP concepts will be there. It uses, yes, it does uses NLP
Okay.
techniques.
Okay, one more question, sir. That what are the different metrics which are used to test an NLP model?
Okay,
Are there any
metrics.
particular metrics?
Metrics in the sense which kind of application, say for example, I have worked on machine translation, so the
Hmm.
metrics to test machine translation models here are like blue clear, then meteor. So those are the techniques which are used to test machine learning machine translation models clear. So uh, you mean to say for which application, that is my question,
Sir,
for what
the
kind of
student
application?
student is not specified,
Okay,
but that was
yes.
what a question. But in general sense, you can answer.
Yes, so in general sense, I will say for each and every applications, there are so many metrics available. Say, for example, for POS, clear, there are also ready-made matrices, okay, available. Yes, but obviously, if I say for Indian languages, okay, you have to go manually. Okay, there are no standard matrices available to test our application, to test our results.
Okay, sir. And sir, can you name few Python libraries that are used for NLP?
The most common one is NLTK. And if I want to go for machine learning, you can go with sklearn. Okay, then if you want to implement deep learning, you can go with
Okay.
Keras and TensorFlow. So these are the libraries which are available. The most primitive form is NLTK, right? So you can start from NLTK, go with sklearn to implement machine learning models. Clear. If you feel that I am having huge amount of data, you can start with Keras models, which is a deep learning model. And in that also, clear, the implementation level is up to sequence model, clear, even RNN model. So all those libraries are freely available and inbuilt, clear, within Python.
Okay, sir. And sir, last question that can you name few applications which are used on the basis of NLP today?
Uh, the most common
Common
is
applications.
yeah,
Yeah.
the machine translation, and machine translation in the background it uses POS tagging. Then whenever you search on Google, okay, it
Hmm.
is information retrieval, okay, removing stop words, okay, coming to the exit, the keywords. That was my next topic, that is TF-IDF, okay, how to find out the keywords. Okay, so there are many applications clear which are available uh, or implemented, okay, in day-to-day basis. Wherever language aspect is there, you will find NLP applications.
Okay, sir. Thank you so much. Sir, we'll just wait for a while. I'll
Yeah,
present my screen to the students
okay,
and I'll just share the feedback link for today's session so we can also get to know about the students' interest.
yeah,
So, students here, You can see, you can just copy the feedback link and please feed in your valuable feedback for today's session. And the feedback link shall be open till 5:30 today. So please ensure that you give your feedback before 5:30. Okay. So, sir, thank you so much for your knowledgeable session on natural language processing and giving us an insight about it. I'm sure that my students would be surely benefited and would have got a better understanding of this concept because you have already taken up the concept along not only with the theory aspect, but you also taken up the practical aspects also. So I must truly say that the webinar would be very informative for the students and it was really excellent. Thank you so much, sir, for taking up your time out and sharing with all of us your knowledge related to NLP. And I'm sure that in future again, whatever we and our students have missed out, right, will surely come again with
Sure, sure,
a next invitation for the webinar. Thanks
sure,
a
sure.
lot, sir.
Yeah, so I'm also thankful to Professor Hina Choksi, also Priya Swaminarayan, and the management of Parul University. I'm thankful to you for giving me this opportunity.
Thank you, sir.